Good morning everyone. This is the circuit of Wheatstone bridge. In this circuit you have 4 resistors P, Q, R and S. As we know, PQ is a ratio arm, so that's why this is the value of P resistor, this is the value of Q resistor. From this knob you can change the value of P resistor. From this knob you can change the value of Q resistor. This is the portion for the ratio arm, P resistor and Q resistor. Here R is variable resistor. Here all P, Q, R are variable resistor and S is unknown resistor. For R, arm R, this is the values which we can change. This is multiplied by 1, means if it is at points at 0, then 0 multiplied by 1 means 0 ohm. 1, then 1 multiplied by 1, that means 1 ohm. Similarly, if it is at the phi value, it points at the phi value, then phi into 1 equals to 5 ohm. Say for example, it is at 0 position. If we further go for this knob, let initially all knob be at 0. This is multiplied by 10. That means if knob is at 1, then 1 multiplied by 10 ohm. 1 multiplied by 10 is 10 ohm. Similarly, if it is at 4, then 4 multiplied by 10, that means its value would be 40 ohm if all other knob are at 0 position. Let it be at 0 position. This is multiplied by 100. That means if it is at points at 2 value, then 2 into multiplied by 100. That means the value of arm resistor R is 2 into 100, that is 200 ohm. Let it be at 0. This is multiplied by 1000. That means if it is at 3 value, if it's no points at 3, then 3 multiplied by 1000, that means the value is 3000. Now if only one knob is operating, then this terminology is applied. If all knobs are used, say for example, this is at 5, this is at 4, this is at 3, this is at 2. So let me tell you the value of this here. I think it is readable over here if I am writing something here. First of all, if I want to know the value of resistor R, then first I will write this value. This is 2 multiplied by 1000. I will simply add all the values to find the final value of arm R. Means to find the final value of R, I will simply add all the knob values. First is 2 multiplied by 1000. I will add, so first add, then this is at 3 into 100, then again I will add this value. This is at 4 into 10, and this is at 5 into 1. So 2 into 1000, that is 2000. 3 into 100, that is 300. 4 into 10 is 40, and 5 into 1 is 5. So my final value would be 2345 ohm. This is the final value of resistor R for this all knob configuration. You can see this. R is equals to 2 into 1000 plus 3 into 100 plus 4 into 10 plus 5 into 1. That is 2000 plus 300 plus 40 plus 5. And final value of R is 2345, means 2345 ohm. This is the way we will calculate the value of arm R. Now here is unknown resistor arm. There are so many values for unknown resistor S, that is R1, R2, R3, R4, R5, R6, R7, R8, R9. So you can simply calculate the value of R1. If you want to calculate the value of R2, then you will use these two knobs. If you want to calculate the value of R3, then you will use these two knobs. Similarly for all the rest of values. If someone wants to calculate the series value of R1, R2, R3, I will simply put one knob here and the final second knob here. If I am putting first knob here and second knob here, then I will have the value of S as R1 plus R2 plus R3, because R1, R2 and R3 are in series configuration in this. Okay. Similarly, if you want to know the value of only R1 and R2 series connection, then you will put your first knob over here and second knob over here. This is simple circuit configuration. This indicates the galvanometer value, galvanometer indication. This is for P, this is for Q, this is for S, and this whole part is for the value R. Here we have push button switch, push to on switch. Whenever I will push it, it will on. If I release it, it will off. See, this is here. That push button switch is here. That means whenever I will connect this circuit to the power supply, turn on the power. If I don't push on this switch, then galvanometer would be not connected into the circuit and indication would be always 0. So without this switch, galvanometer indication would be always null. Means 0 value, because it is not connected to the path B and D. That's why. So this is the power switch. This is push button switch, which will connect galvanometer to these 2 points, so that we can find the value of galvanometer. Okay. As a Wheatstone bridge, we know at balance condition the equation is R1 divided by R2 is equals to R3 divided by R4. This is R1, R2, R3, R4. So if I write this in terms of PQRS, then it would be P divided by Q is equals to R divided by S. As my S is the unknown parameter, if I take the value of S, then it would be P divided by Q into R. We have the ratio of P and Q into the final equation, which is having the balance condition equation for Wheatstone bridge. That's why P and Q is also known as ratio arm, as written over here, ratio arm P, ratio arm Q. Okay, I think I am clear up to this. We will first connect the circuit. Here the procedure steps are given here. So let me start. First of all, here first step is connect any resistance from unknown S to the bridge circuit, i.e. in between point C and D. We will connect any unknown resistor between C and D, yani ki unknown arm. This is the first point. First point would be connected to here. Say for example, I am connecting R1 resistor first. So this is connected over here and the second terminal is connected at D. That means I am connecting R1 at a place of unknown resistor S. That means I want to find the value of R1 over here. Second step is connect point A to A dash. We will find first where is A and where is A dash. Here is A and here is A dash. It will simply connect our ratio arm R to the circuit. So we are connecting A to A dash, then E to A, E to A, yani I will connect E to A over here, and F to C. We will go for the connection F to C. Here is F and this is my C point. Now put the ratio arm PQ at appropriate resistance value. Look, in the equation we have like P divided by Q. I will simplify this. If these two values are equal, then I can simply cut this and whatever the value of R I'll get would be the value of unknown resistance S. So I need not to do any calculations if I want to calculate the value of unknown resistance S. If I have the same value for P and Q. So let me take the both values at 100. Let P is 100 and Q is at also 100 position. After that, put the mains on off switch to on position. First I will supply on. This is the power on. I will on this as here is the push button switch which is not pressed, that why galvanometer indication is always 0, null detection, because your galvanometer is not connected over here because the switch is open. Now what we will do is we will set the balancing resistance R. Look, our procedure is like, we will first put P and Q at fixed value. I need to find the value of unknown resistor, that is R1. So I will simply change these values. Before changing the value of resistor R, I will simply put all the knob value of R at 0. This is the initial thing which you need to follow. I will put all the points at 0 position. After that, what will I do? I will press this switch so that galvanometer indication would be some value, that is the current value which it is going to show. Now I will change the value of resistance R so that I can make it 0. Look, Wheatstone bridge के लिए we are going to use the equation, that is R1 divided by R2 is equals to R3 divided by R4. This is the balanced condition equation. And as we know, balanced condition means galvanometer current must be 0. So I will change the value of resistor R so that this indication becomes 0. So I will change the position of first of all multiplied by 1 pointer value so that I can see after increasing this it is decreasing. Dekho, at the point of 3 the value is around minus 15. At point 4 it's minus 12, but that means it is decreasing. So I need to further increase this value so that it can become 0. I'll move to 5, it's again decreasing. I'll move to 6, I'll move till further it becomes 0. So I'll go to 7, we'll wait for some value, then I'll go to 8. We will wait for the settle of this value. After that we will go to 9. It's minus 1 around. I'll go to 10. It's 0.49 or 0 minus 0.01. That means it is nearly about 0. If you can consider, we may consider it as nearly about 0. If I am not properly pressing this switch, that's why its indication is varying. Otherwise it's nearly about 0, minus 0.00, or it's actually showing 0 value, 0.00. That means my galvanometer deflection is 0. That means the value of galvanometer current is 0. So we can say that balance condition is achieved. Balance condition is achieved. Then I'll note down the value of PQRS and I will find the value of S. This is the procedure actually. So this is the balance condition. So my first reading is done. I'll release this switch. I'll note down the values of PQRS. That is, first value is P. P is, as I have taken 100 ohms. Then I'll write the value of Q. Q is again I have taken 100 ohms. Right? S is unknown, so I need to find out that. Now I'll find the value of R as per this. I'll find the value of R as per this. But as we know, multiplied by 10 is 0, multiplied by 100 is 0, and 1000 multiplied by point is also 0. So it would be like 0 multiplied by 1000 plus 0 multiplied by 100 plus 0 multiplied by 10 plus, here the value is 10, and multiplied by 1. So it will be 0 plus 0 plus 0 plus 10. So my value of R would be 10 ohm. Now I want to find the value of S. So I'll go to this equation, that is S is equals to P divided by Q into R. P is 100 ohm, Q is again 100 ohm, and R is 10 ohm. 100 ohm would be cancelled out, and my value of unknown resistance S is 10 ohm. This is the actual value of unknown resistance S. Now we will verify this value by using multimeter. Let me find multimeter in 1 second. Here is the multimeter. What will I do? I'll switch off the supply. Simply I'll disconnect the resistance R1 because I want to know the value of R1. So I will use this multimeter, put this 2 points over here and try to read the value of this resistor. Wait. Look, it's showing value 11 point something or 10.4, 10.4, 10.6, 10.5. So my multimeter reading is 10.4 ohm. So what value we have found is nearly about the exact value of the unknown resistance. This is the way how we can calculate the value of unknown resistor using the Wheatstone bridge. Thank you.